Welcome guys, me just explain him the equation of continuity. Me make him finish, so me just explain him soon. So look him, equation of continuity and based on top law conservation of mass. You mean on a creating or destroying mass, one kind of some conservation of energy. So basically, I mean you some flow rate plus la entry blow waraya, and one kind of them flow rate blow exit or you can talk mass flow rate layer and one can them mass flow rate layer. So one like this equation is very important. You talk the equation of continuity. You just think so Q1 is equal to Q2 kind of same. QM or flow rate. Now you may try kisah column lower this layer. So suppose we talk this layer 1 meter this layer length na timer 1 seconds you measure unit. So suppose column lower and move within 1 second so it's 1 meter distance then you can make it come up with plan and make him like column L na T. Lo make him simple that's all you can talk area times length divided by T and by giving me volume divided by T which is the flow rate. So flow rate and basically I mean you same how much volume lo wara all move pass long 1 plus seconds kind of same. Mass volume lo wara and move pass long 1 plus seconds. Time all go speed inside the pipe kind of same. And fluid can be gas or liquid. Okay, now this la area times length equals to volume. And basically I'm set to cube. So we make him volume by length times width times height. So length times L times L L cube dimension below volume which is basically in terms of unit SI unit by meter cube so lo lo set lo pipe we got area penis length times width mix lo pi r squared lo formula below cross sectional area more set to pi r squared. So area mixing penis times L now this la L you make your same height so times L now and by give me volume. Now lo make him come up flow rate now divide by time divide by time now make him flow rate now suppose you can think this like equation the speed equals to distance on time you can look him same area times sla length distance lo wara move lo ya na ko lo ya on lo ya no ko lo ya divide by time distance divide by time dml tasole is equals to area times speed or velocity which is equals to volume on T which is basically the flow rate mq now from this equation you can talk q1 equals to q2 let's say 2 plus points and now you can talk a1 v1 equals to a2 v2 now I'm slam equation of continuity equation of continuity I'm slam equation now lo side flow rate I mean mesh flow rate and basically I'm asking lo how much mesh blows la wara all pass by lo 1 plus seconds kind of same per second mesh of fluid flowing per second kind of same. Now suppose you talk V1 inside this equation into V1 is equals to V1 which is volume at 0.1 divided by T1 which is basically Q1 is equals to volume 2 divided by time 2. Now suppose we talk density equals to mass on volume. Now you like mass flow rate so you make mass come subject so by density times volume now you can do same density times volume 1 is on T1 is equals to density times volume 2 on T2 kind of same. Now we can talk instead of density times volume we put in back mass here so it becomes mass 1 on T1 equals to mass 2 on T2 so basically mass on T mass flow rate kind of same. So the conservation of mass 2 plus mass 1 can mass flow rate mass 1 can time mass flow rate lo upside Now, this la equation regardless of the area, whether this is smaller or this is bigger, are still valid. Okay, because depend on area na velocity. So regardless of the area, still equation valid. So in order for it to be valid, must time you increasing speed lo upside lo 0.1. Sorry, time you increasing area lo upside a1, speed 2 must decrease by balance. So suppose you decreasing area lo upside lo 0.2, velocity it's a speed must increase. So basically what it means, time you increasing area, velocity go down. Time you decreasing area, velocity go up. Okay, so for example, say me got garden hose example. Garden hose, suppose you say was on time hose. Now, time you putting finger blue, now you squeezing this la opening blue suppose la nozzle no gata, but them hose open nothing, so time squeezing. Cannot see reducing area blow, cross sectional area blow, entry blow waraya. Sorry, exit blow waraya. So no waraya by speed no go through. V velocity speed antap na area come down cannot see. Now time you losing finger blue, area go big plug in. By velocity by go down, no waraba punon come down so. Na area go big plug because you lose finger blue, go big plug in cannot see. So that's all. So in any question or assignment or quiz or any, so give him V2 unknown, I will give more number values. You can make him V2 come up subject now, you calculate him. Now here to so give him time, you got slowly equation, volume times stop kind of same. Now mass flow rate and basically M on T. So that's all. Thank you.